Right, so we're going to look at some stoichiometry examples that go along with the intro to stoichiometry notes. So if I just go through these, example number 1 is that you have 527 grams of zinc nitrate, and that contains how many nitrogen atoms. So if you start off by looking at your steps that were listed on your note sheet, they look like this with the 4 steps. First step is to write down what you know, and then the second step is to write down your goal. So if you go back over here, to write down what we know from our problem, the problem gave us that we have 527 grams of zinc nitrate, and zinc nitrate is ZnNO3 2. And then we're, of course, going to draw our line, and we're going to write down the goal. It says how many nitrogen atoms. So we want atoms of nitrogen. If we look at this, to figure out how many steps our problem has, if we're looking at our roadmap, we're converting from grams to atoms. So that uses both steps on the roadmap. Plus, we're changing our label from zinc nitrate to nitrogen, so we're going to add one more step. So we have a total of 3 conversions, or 3 steps used to solve this particular problem. We know that whatever unit and label we have over here, we want on the bottom so that we can cancel it out. So I'm going to write down grams of zinc nitrate. And then this is where most of my students get stuck. They're like, okay, great, now what do I do? The first thing you need to ask yourself is, where do I find my grams from, or my mass from, for any particular chemical? If I look at my roadmap, it tells me that my number of grams comes from the periodic table. So I need to find a periodic table, and then we can go ahead and add up the masses of all of the individual elements. Be careful, because they are not listed as zinc nitrate, obviously, on the periodic table. So you need to look up the actual masses and add up them for each of the individual elements. So if you look at zinc on the periodic table, you have 1 zinc in this formula. So we're going to take 1 times the mass of zinc, which is 65.38. We have 2 nitrogens. Be careful that 2 distributes to what's inside the parentheses. So for nitrogen, we have 2 times 14.007. And then for oxygen, we have 6 of those. So we're going to take 6 times 15.999. If we do all of that, we end up with 65.38. We end up with 28.014. And then we also end up with something close to 96. So I'm going to round and say 96. You guys don't round. You'll have calculators with you. So if I add all of this up, I end up with something that looks a lot like this. So you have 14 plus 5 is 19, carry the 1. That would be 189.394. This number that we just added up is the mass, or the number in grams, of zinc nitrate from the periodic table. So we're going to look and write 189.394 here. On the other side of that conversion off of our roadmap, we have 1 mole. So we're going to have 1 mole at the top of our line. Make sure that your label has to stay the same. So we still have zinc nitrate here. And we're done with our first step. Our grams cancel out, and we're left with moles of zinc nitrate, which is closer, but definitely not what we want. So then we need to cancel out moles of zinc nitrate. So I'm going to put moles of ZnNO3 down here. And then if I don't know what I want to go to, I'm going to tell you guys, put your goal unit on the top. So if I put atoms of nitrogen, then you can look at this and ask yourself a couple of questions. How many things are changing between these two units? My unit is changing from moles to atoms, and my label is changing from zinc nitrate to nitrogen. I'm not allowed to change two things at a time. I'm only allowed to change one thing. So instead of going to atoms, I'm going to make this go to moles. And remember that thing that I told you to write down next to subscripts and coefficients on the notes video? That subscripts and coefficients give the mole to mole ratio. So whenever I have moles on both sides of my fraction, moles on top and moles on the bottom, I need to look at subscripts or coefficients. In this problem, I do not have an equation, so I'm not going to have any coefficients to look at, meaning I need to look at my subscripts that are written over here. If I have one of my big molecules, then how many nitrogens do I have? And again, be careful. We had to figure it out over here too. We have 2 nitrogens. So it's going to be a 2-to-1 ratio. Now that ratio is not always going to be the same. It can change depending on what your compound is listed as. So we have moles of zinc nitrate that have canceled. We're in moles of nitrogen. We're really, really close. We want to cancel that and get 2 atoms of nitrogen, meaning we need to use our roadmap one more time. If I have 1 mole, that means that I have 6.022 times 10 to the 23rd atoms of nitrogen. Now, if I were to multiply or solve this problem, remember I start with whatever the problem gave me, multiply literally all the way across. If I have something that has scientific notation, put that in parentheses in your calculator so it doesn't mess up your order of operations, and then divide everything that is on the bottom of your calculation, and then hit enter. When you hit enter, you should end up with something close to 3.35 times 10 to the 24th atoms. And be careful, make sure you have your label with that. It's not atoms of zinc, it's not atoms of nitrogen, it's not atoms of carbon. It is atoms of nitrogen, it's not atoms of oxygen. And you can see that this kind of gets a little bit messy, even though I have color coded this or changed my color throughout the problem. But go ahead and box in or circle the final answer for me so that I know, yes, this is my final answer. Be careful with your number of digits again. If you remember when we were doing conversions the first time, your number of digits has to equal whatever number of digits you start with. So we had 527 over here, which was 3 digits, so we need 3 digits in our answer. So we end up again with 3.35 times 10 to the 24th. Now I'm going to skip example 2 and go to example number 3. We'll do this, and then I'll have a second video for the other 2 examples on your notes. So your problem here says, given that 0.25 moles of water are produced, how many grams of oxygen are used in the reaction? So the secondary thing is how many grams of hydrogen are used. If you were to look at this problem and solve or set it up, you start out with 0.25 moles of water. So again, H2O, hopefully you know that. And we're looking for how many grams of oxygen. So we want grams of oxygen. Now be careful, it's not just O. If you look at the problem or the equation given to you, it's O2. So oxygen has to be listed however it is in the problem. If we're counting our number of steps, we're going from moles to grams, which is only a 1-step problem, but then our label is also changing from water to oxygen. So we have a 2-step problem here. So you need to make sure that you do both steps before you try to solve anything here. So we're going to, first of all, choose our label and our unit from our first step, or from our problem, actually, and write that down. So we're going to cancel out moles of water. And again, if you don't know what you want to go to on the top, then write down your goal unit. So we have grams of O2. And then ask yourself how many things are changing. We're changing our unit from moles to grams, and we're also changing our label from water to oxygen. We can't change 2 things at a time. So instead of making it grams, I'm going to make this say moles. My mole to mole ratio, again, comes from either a subscript or a coefficient. That's what our notes tell us. So I have an equation for this problem, meaning I'm going to look at a coefficient here, not a particular subscript, because I'm changing my substance. So if I look, what's in front of water is a 2. So in front of water in my problem, I'm going to put a 2. In front of oxygen in my equation, I have a 1. So in front of oxygen in my problem, I'm going to put a 1. It's not always going to be a 1 to 2 ratio. I think before it was a 2 to 1 ratio. Sometimes it's going to be a 3 to 4 ratio. It depends on what equation or what subscript you're using for this particular mole to mole ratio. So moles of water cancels out and I'm left with moles of oxygen. That's not exactly what I want. I want moles of oxygen to now cancel. So I'm going to put that on the bottom and get to grams of oxygen on the top. If I need to remind myself, where do I get my grams number from? Grams comes from the periodic table, or your mass comes from your periodic table. Oxygen on the periodic table is 15.999. So for the sake of this video, I'm going to round that to 16. You guys do not round on your problems. Otherwise, it kind of messes up your final answer and your rounding. So you don't round. I'm going to round on here just so that it's a little bit easier to do in my head. So I'm going to start with 16, but I have 2 oxygen, so I need to multiply that 16 by 2, which means I have 32 grams of oxygen. And if you look at your roadmap, 1 mole is always on the opposite side of grams. So moles is going to then cancel out. I'm left with grams of oxygen, which is my goal. So then I can solve. If I have 1/4 or 0.25 times 32, I get 8 divided by 2. I end up with 4 grams of oxygen for my final answer. Just as a fast reminder how I solved that really quickly, start with whatever it is that you are given in your problem, multiply across the top and divide across the bottom. And then be sure that whatever number of digits you start with, so I had 2 digits over here, I need to end with 2 digits. My answer is a whole number, so I need to add a 0.0, so I end up with 2 digits in the answer. I hope these examples help. There will be one more video of 2 more examples, just with some basic compound and reaction stoichiometry. Hopefully, like I said, hopefully this helps.